So a quick example for string quartet, a very short example. So we need pattern. So I have a variable patterns, and I can generate algorithmically this pattern with macro-mn. We need some pitches naturally. I can make a scale starting on D4 with 11 pitches, alternate 2, 1, so this is a octatonic scale, or Messiaen transposition mode number 2, you know. And I will, so that's the scale, basically. And I will random sample, maybe just 8 notes in that scale as pitch material for 1 bar, for example, something like that. Now we need length. I will just generate some lengths. I will random sample 16 value. So it could be a 16 or a rest of 16. So this is a 4/4 bar, you know. And each time I evaluate it, I get different rhythm, but I will use length legato to remove the rest and to have something continuous. So, and for our dynamic, so velocity, I'm just random pick some dynamics. Piano, mezzo piano, mezzo forte, and forte. And now I have a kind of generator of pattern. Each time I evaluate, I get something. And to generate our pattern, so we want several, not only one, so I can set the number of pattern, and let's say we want 8 patterns, and here I will just gen eval, it means gen evaluation, so gen eval number of pattern, this. So now I can get 11 patterns, 8 patterns. So we have the patterns. Now we can start to compose the song. Let's say the size of the song will be 24 bars. And we will generate some index number to call that pattern. So something like index 1, and you can generate random number. So we random number size between 1 to number of patterns. So this gives us some index number, and because we are doing a string quartet, so 4 lines, index 2, index 3, index 4. So now we have our list of patterns. Now we can do the instrumentation. So violin 1, maybe control a bit the ambitus, and maybe the transposition, pitch transpose 12 for the first violin, and we will map the index to the pattern. So to do that, we will use the function vector map and patterns and index 1. So this is our violin part, and we can do the same for other part. So violin 2, maybe no transposition, and take the pattern inside index 2. The viola, maybe minus 12, text pattern index 3, index 4 for the cello, violoncello. The ambitus is violin, here is viola, and here is cello. So now we can already have a quick look with previous score. String quartet. My cello minus 24. So let's evaluate everything. And now we can improve a bit this. Let's say we want to control more the harmonic path. So I can define the harmonic path. I'm using the function Tonality-map, tonality series. And let's say we will use a Dorian mode followed by a Lydian mode. Maybe the root for each of that mode will be, let's say, D4 and F4. And yes, to get a correct mapping, we have to specify map octave. So this is our harmonic path. Maybe an harmonic rhythm. So that's the cool things with tonality system in Opusmodus. You can specify the harmonic rhythm. Let's say we change every 4 bits for the Dorian, and the Lydian will stay only for 2 bits. So it will be Dorian for 4 bits, Lydian for 2 bits, and a loop, and so on. So this is the harmonic rhythm. And now just apply this. So we set F violin 1 point, let's say P, for path, harmonic paths, and I will use the function Tonality-map to call the tonality series. So Tonality-map, I apply the path defined here. I apply to violin 1, and for the harmonic rhythm I use time, harmonic rhythm. So do the same for the other instrument. Now we have everything, so I generate again everything to check. So the mapping is done now. And now we just can call that with previous score. And have a look. So we will get the Dorian and Lydian map on the violin on all the instruments, following these roots and following this harmonic rhythm. 4-beat, 2-beat, 4-beat, 2-beat, and so on. This is my personal Opusmodus system, but if you use it in Opusmodus, you can just use GM to get the general MIDI output. And naturally, you can export your score here to Music XML, to any score editor or whatever you want. Goodbye, see you soon.